All right, today we are diving deep into the world of global shipping. And believe me, it's a world where a single tiny prediction can have massive, and I mean massive, financial consequences. We're talking about trying to predict exactly when a huge container ship will arrive at port, which, as it turns out, is an incredibly complex problem with literally billions of dollars on the line.
I mean, think about that for a second. It might sound like an exaggeration, but it's the absolute reality of modern logistics. If a ship shows up just a few hours late, or even a few hours early, it can throw the entire supply chain into total chaos. So the real question isn't just if we can predict its arrival, but how ridiculously accurate can we get? Because in this game, accuracy is everything.
And this gets us right to the heart of the matter, what researchers called a port's prediction problem. Nailing a ship's estimated time of arrival, the ETA, is absolutely critical. It's the linchpin that makes everything else in the supply chain, well, work.
Just try to picture it. If a port doesn't have a reliable ETA, how can it possibly schedule the right number of cranes, or the trucks waiting to haul the containers away, or even have the warehouse space ready? You can just imagine the domino effect. One little delay creates this massive traffic jam, which means wasted fuel, wasted time, and yep, you guessed it, higher prices for all the stuff we buy.
So what's the solution here? Well, researchers are turning to the big guns, data and machine learning. In one fascinating study, they basically set up a competition, pitting 3 different digital prediction models against each other to see which one could best navigate the chaotic seas of maritime data.
So let's meet our contenders, shall we? In this corner, we've got a classic, super simple approach. And in the other corners, 2 highly advanced, really complex models. The goal here is simple. Find out which one can predict the future with the fewest mistakes.
First up, we've got linear regression. You can think of this one as the old-school veteran. It's a really straightforward model that basically assumes everything happens in a nice, neat line. It's like looking at a ship's pass speed, drawing a perfectly straight line on a map, and saying, there, that's where it'll be tomorrow. It's simple for sure, but is it actually effective? We'll see.
Next up is XGBoost. Now, this model is a total powerhouse when it comes to efficiency. The best way to think about it is like having a whole team of hundreds of little expert guessers. Each one takes a quick look at the data and makes its own prediction. Then they all vote, and the most popular guess wins. It is incredibly fast and amazing at spotting patterns that other models might miss.
And finally, our third contender, the LSTM model. This one is the super sophisticated detective of the group. It's not just looking at one data point from yesterday. Oh no, it looks at the entire journey, the whole sequence of events that led up to this moment. It has what's called long short-term memory, which lets it remember important details from way back in the voyage to understand the full context and make a much more intelligent prediction about what's going to happen next.
Okay, the models have been trained, and the data has been crunched. It is time for the performance showdown. Let's get right to the results and see which of these contenders actually came out on top.
Okay, wow. What's really incredible about this chart is just how clear-cut the results are. We're looking at something called mean absolute error, or MAE. Just think of it as the average number of hours the prediction was off by. So obviously, a lower bar is way, way better. And the difference is, well, it's stark. Just look at this first bar for linear regression. Its error is through the roof. Now compare that to the tiny little bars for XGBoost and LSTM. They're both performing incredibly well.
So, just how bad was it for linear regression? Well, its errors were a staggering 450% higher than the LSTM model. That is not just a little bit worse, that is a complete and total failure to understand what's actually happening out there at sea.
And that's the key takeaway here. A ship's journey is not a straight line. It's messy. It's affected by unpredictable weather, ocean currents, all sorts of traffic at the port. All of these complex, non-linear factors. A simple model like linear regression, it just can't keep up. It's completely out of its depth.
But hang on. Let's dig just a little bit deeper, because this is where it gets really interesting. When we look at another measurement, this one's called root mean squared error, and all you need to know is that it really punishes big one-off mistakes, we see something fascinating. You can see the 2 bars for LSTM and XGBoost are incredibly close. In fact, XGBoost actually has a tiny, almost invisible edge here, just 0.8% better. This suggests it might be just a little bit better at handling those huge unexpected delays.
But even with that super close race in one specific area, when you step back and look at the whole picture, one model was just consistently better across the board.
The research paper itself puts it really plainly. The LSTM model was the undisputed accuracy champion.
It beat XGBoost by a small but important margin in overall error, and it just absolutely demolished linear regression with an 82% better score.
And these numbers right here, they really tell the whole story. With the lowest average error and the best all-around performance, the LSTM model, that sophisticated detective, its ability to understand the full context of a ship's journey made it the most precise prediction tool in this whole competition.
So that's it. Case closed, right? Everyone should just use the LSTM model from now on? Well, not so fast, because the real world is always a little more complicated. Which brings us to the final and maybe the most important takeaway from this entire study.
And this slide lays out the critical trade-off perfectly. Yes, LSTM gave us the most accurate answer, no question. But that incredible precision comes at a cost. It's slower, and it needs a lot more computing power to run. XGBoost, on the other hand, was almost as accurate, but it's significantly faster and way more efficient to operate.
So what this all boils down to is that the best model isn't a simple one-size-fits-all answer. It really depends on what you need. If you're a company that needs the absolute most precise prediction possible and you've got the money and the computers to back it up, then yeah, LSTM is your winner. But for an operation that needs fast, scalable, and still highly accurate predictions, well, the speed and efficiency of XGBoost make it a really, really compelling and practical choice.
And that really leaves us with a final question that goes way beyond shipping. When you're faced with a complex problem, what's the real goal? Is it to find that single, perfect, most accurate answer, no matter what it costs? Or is it maybe better to find a highly effective, practical solution that gets you 99% of the way there, but does it faster and more efficiently? It's a trade-off that pretty much defines innovation in almost every field you can think of.